Now we're going to dimension this. So up here, dimension, and it's just basically a click. So you don't click and drag, you just click your first point, click your last point, and then move down and click to place. Okay, so now I know I have to cut my leg at 190 wide, and I know from click, just zoom right in here. I might leave that one off. I might take that one from here. So I've got the width of my leg there, dimension from here to here. If I come out straight, there we go, that's the finished height of our leg. Okay, and I can take the thickness of my leg from here to here, out on the same angle. Now that's actually 19, but it's because of the angle on it. So what we can actually do is I'll come back to it. That's that one there. So that's the legs done. The cross beam, I can take a measurement from here to there. Of course, that one goes on the angle. Dimension from here. There we go. 70. Click. The width of it, I can take down here. Just gonna get rid of this 19 one for now. So that's that one done. And in the top view, I'll do the top of it. So we're going from our width here to there. It's 190, from there to there, 350. I want to place our cross beam right in the middle. So I'm going to show that it's the same dimensions from there to there. Okay, and then we know he's in the middle. Probably want to know some more measurements on our cross beam. So we want to know from here to here is 15. From here to here was 20. I might take that up the top. And that gives us that angle there. I want to know how far in my domino is. Not my domino, sorry, my dowel. So I might say from here to the edge here is 27, but it's actually 30 to the dead center. Might be able to see that better from the top. Okay, so to the center of the circle, you follow that projection line up, is 30, and I might just go here and go diameter dimension of that circle there is 6. Okay, pretty cool. So let's just ask a few questions now. Do we have enough information to create the top? We know the length, we know the width, we don't know the thickness, okay? So I'll come down to the side view and I can show the thickness there. So yes, we know where the center line is, we know it's 30 million from there, we know there's a 6 diameter hole there. We don't know how deep that hole is though. We can show that here. So dimension from there to there is 10. So that hole's 10 mil deep. So we know that. Okay, next piece now, let's ask a few questions. Do we know the length of this crossbeam? Yes, it's 350. Do we know its width? Yes, it's 70. Do we know its thickness? No, we don't. So let's do that one there. So from the side view, we can see the thickness there of 90. We know to create this angle, we can come 15 mil down there. We can come 20 mil in from the edge, gives us that point to connect it. We don't know how far in from that point there is, okay? So let's dimension that. From there to there is another 20 mil. So 40 all up to get us to that point. We don't know this angle. So let's see if we can dimension an angle in here. There we go. Angular dimension between there and there. 80 degrees, which is really 10. And the height from here to here for our half flap. Half kind of gives it away. So between here and here, it's 35. Okay, let's just move our screen around. All right, do we have enough information now to make that whole piece? It's 350 long, 70 wide, 19 mil thick, sorry. Down to there's 15, into there's 20, that gives us that angle. We know we come another 20. To get that point there, we know that's 10 degrees up because it's 10 off 90. We know that goes to the 35 mil mark halfway up. And our legs are 19 mil thick. Let's see if we can find a way to do that. I know there's a way. I'm a bit rusty. Here we go. We tried that one. Angular. Try that one. We might just make a note on the drawing that all timber is 19 mil thick. There is a way to do it. We could go like this, I believe. And so there we go. There he is. Cool. Bit tricky. If you can't get that one to work, guys, don't worry about it. Okay, we'll just put a note here that all timber thicknesses are 19 mil thick. Okay, so the legs, we've got the start length. There. Cool, that looks done. Probably the one thing on the crossbeam we don't have is how far in, there we do, how far in the dowel, so it was 30 in, 6 mil, we don't have the depth. So we need to put this one on here. So dimension from there to there. I might actually do that the other way around. I'm going to start from the bottom of it. So I'm going to start from there and go to there. And that just puts the number up the top instead of down the bottom through all those lines. Okay. Let's set that done so we can make the top, we can make the crossbeam, we can make the legs. Guys, that's practically it. One last thing, some text down here. And you need to write in here in caps. Drawn by, and then put your name. Oops. Type it. Miss Woods. And can you also write under there SCCC Industrial Technology Timber colon E9 Core Module 1. Great. Okay, that's it. Well done, guys. It's ready for printing now, so just go output PDF, sheets. Here's your sheets down here, so at the moment there's just one. So you can just go current sheet, just go open PDF, go OK. Save that to where you need to save it. Stage 5, new folder, drawings. Footstool. orthogonal. Orthogonal means it shows you your top, your front and your side all lined up. So you'll notice that if I project that line up, it lines up with our top view here. If I project it across from the top, it'll line up there. Okay, done. Okay, save. And it's just going to give me a preview now. There it is. So guys, if you've got ink at home in your printer, please print that off so that when we come back to school, we can have that in our A4 display folders, and you guys will be able to take all your measurements from here rather than asking me what all the measurements are. Okay. Thanks for watching. Any questions, again, email me and I'll do my best to help you out.